A 100 milliliter graduated cylinder will have tick marks for each milliliter. You, as the scientist, get to estimate the next number, which will be 1/10 of a milliliter. This allows you to figure out the relative proportions of each substance. Because I'm using a graduated cylinder in this class example, I'm going to erase the centimeters and leave only the millimeters to represent that I'm using a graduated cylinder. If I take a look, the total soil column, that is the topmost layer of the clay, that is 33.7 milliliters. I can note whether there's any floating material, and then the top layer I do by taking 37.7 and subtracting 30.3 to get the thickness of the top layer, and that is a clay layer. The middle layer I get by taking 30.3 and subtracting 27.3 to give me a 3.0 millimeter layer of silt. The sand layer is very simple because that is 27.3 milliliters in my graduated cylinder. To calculate the thickness of each layer as a percent of depth, I'm going to take the thickness of the layer, the top layer in this case, divided by the total thickness, which is 33.7 milliliters. When I do that math, I get 0.1009, and I multiply it by 100 to get a percentage. The middle layer is 3 divided by 33.7, and the bottom layer is 27.3 divided by 33.7. 10.1% for clay, 8.9% for silt, and 81% for sand. In order to use the soil triangle, I'm going to correlate sand, clay, and silt on this triangle here. Let's start with clay. I find clay is on the left-hand side, and so I look for 10.5. And I know that my soil is going to be somewhere on this line. Silt, I look for 8.9, which is about here, and I run the silt along this line. And sand, I look for 81%, which is about here, and I run on this line.